Thing we'll be looking at is composite function. So function that relates a function. I call it a function of a function. So assuming that we have a function y is equal to 2x plus 1 and I write it as f of x is 2x plus 1. That is when I input x, any value of x, that is function of input of x, I'm going to get a corresponding output which is 2x plus 1. Do you get? So now I now have something like this, f of g of x. This is telling me that instead of putting a variable x to get a corresponding output, I'm now putting another function of x there. Do you get? So let's assume that now this my f of x is 2x plus 1. So when I input x, a variable, I got 2x plus 1. So definitely if I input a function, I'm going to get 2. My input now is now g of x, so that will be g of x, then plus 1. So that is what function of function is telling you. It's telling you that this one we call it function of x, but this one now we call it function of another function of x. So we just shorten it to call, we just call it function of a function. Alright, so let's assume that we have this question, f of x is equal to 2x squared plus 3x minus 1, and we have g of x is equal to 3x minus 1. These two functions are function of x. So now I know that my function of x is 2x squared plus 3x minus 1. That is when I input any value that is x, I'm going to get a corresponding value that will be 2x squared plus 3x minus 1. So that means that if I want to do f of g of x, I will literally replace the value of this my input with my new input, which is g of x. So that is, instead of saying 2x squared, now my input is now g of x. What is my g of x? 3x minus 4. Alright, so then I squared plus my input now is no more x, is g of x, which is 3x minus 4, then minus 1. Do you get? So to make it easier for us, instead of expanding this, I'll just write this relationship in maths. When you have a plus b all squared, it's the same thing as a squared plus 2ab plus b squared, telling me that a and b can be anything. So in this case, my a is 3x and my b is minus 4. So if I say 3x squared, that is saying 3x all squared. So that is 3 times 3, which is 3 squared, that is 9, times s squared, so that is 9s squared, plus 2ab. So 2, my a is 3s, my b is minus 4. So 2 times 3 is 6, times minus 4 is minus 12. So that is minus 12x. Then plus b squared, my b is minus 4. So minus 4 times minus 4 is like saying minus 4 times minus 4. Minus times minus is plus. Then 4 times 4 is 16. So that is plus 16. Then I will expand this. 3 times 3s will give me 9s. Then 3 times minus 4 will give me minus 12. Then minus 1. So now I will expand this as well. That will give me 18s squared. And 2 times minus 12 will give me minus 24x. Then 2 times 16 is 32. Then plus 9x minus 12 minus 1. So now I'm going to simplify like term. When I say like term, the one that have the same thing in the front. This, let's assume this s is orange, this one is mango. You cannot add the orange and mango together, but you can add the orange and orange together. Do you get? So the one that have the same variable in front, that is the one you can add together. So this 18s squared does not have another thing that have s squared, so we just leave it like that. This minus 24x plus 9x, assuming x is mango, so it's like saying minus 24 mango plus 9 mango, that is minus 15 mango. Do you get? So that is, and then you add 32 minus 12. 32 minus 12 is 20 minus 1, that is 19. So my f of g of x is simply this. And then what of if it is g of f of x? So normally my g of x is 3x minus 4. So I'm literally changing my input to the new input now, which is f of x. So 3 into brackets, my input now is now f of x, which is equal to 2x squared plus 3x minus 1. Then plus this, minus 4. That is there. So I will expand 3 times 2, that is 6. That with that x squared, that is x squared. 3 times 3, that is 9x minus 3. So that will minus 4 again. So that will give me 6x squared plus 9x minus 7. So we can see clearly that f of g of s and g of f of s, they are not the same thing. So in generally, f of x and f of g of s and g of f of s cannot always be the same thing. They are not always the same. They can be the same, but not always. Do you get? So you cannot just conclude that if you do it this way and you do it this way, you get the same answer. That is wrong. Do you get? And also, let's assume that we have something like this, and then we are now asked to find f of g inverse of x. What is this telling us? This is telling us that, first of all, we want to change our input from x to g inverse of x. So g of x itself is 3x minus 4. So let's assume that g of x is y. So that is y is equal to 3x minus 4. So finding the inverse of a function is simply changing the input to output and output to input, like I've explained. So we want to make s dissolve a formula. You take this minus to the other side. From minus, it should change to plus. So that will be y plus 4 is equal to 3s. Then you divide both sides by 2. By 3. So this will cancel this. So you have y plus 4 all over 3 is equal to x, or you should say to save space, or to say x is equal to y plus 4 all over 3. But to let it make sense, we will change, because we all know why s is always having something to do with input and y is having something to do with output. So to make it come more general, so we just change s to y and y to x to avoid confusion. So y is equal to s plus 4 all over 3. So my g inverse of x is now equal to s plus 4 all over 3. So this is my g inverse of x. So if I was now asked to find f of g inverse of x. So my new input is not x anymore. It's now g inverse of x, which is s plus 4 all over 3. So now my f of x is what? My f of x inside the question is 2s squared plus 3x minus 1. And my g inverse of x, after solving it, I got s plus 9. Is it plus 9? No, s plus 4 all over 3. So that is s plus 4 all over 3. So if my f of x is this, then f of g inverse of x, I'm literally changing my input to this new input from x to g inverse of x. So anywhere I see x, I will replace it with s plus 4 all over 3, which is my g inverse of s. So square plus 3 into bracket s plus 4 all over 3, then this minus 1. So this case, you have to be 100% careful so that you not do a mistake. So whenever you have a all over b all squared, the same thing as a square all over b squared. That means that you can square the numerator separately and the denominator separately. So it's like saying 2 into bracket s plus 4. This 2 is separate, it's not inside the bracket, so it's independent. So s plus 4 square all over 3 square, which is 9. So then plus 3 into bracket s plus 4. So 3 times x will give me 3x. Then 3 times 4 will give me 12. I just expanded. That means numerator and denominator, they are independent of themselves. So all over 3. These 3 itself can cancel themselves. So this would have been giving me s plus 4 only. So let me simplify it. So that will give me s plus 4. So no numerator again. So it's this minus 1. So now I'm going to apply this shortcut again, so make it easier. 2ab plus b squared. So I'm setting my a to be s and my b to be 4. So a square will be s square. And what is my s square? My s square is s square. And my 2ab, that will be 2 times x times 4. So 2 times x times 4, that will give me 8x. And my b square will be 4 square. What is my 4 square? 16. Then everything all over 9. Plus this s plus 4 minus 1. So 4 minus 1 will give me 3. So now, this is what I'm simplifying. So let me expand this. 2 times s square, that will give me 2s square. Plus 2 times 8, that is 16s plus 32 all over 9. Then plus s plus 3. So now, I'm just going to take the SCM. So the SCM of this x same as s all over 1, and this one is 3 all over 1. So the SM is 9. So 9 divided by 9 is 1. So I'm literally multiply what is here as 1. 1 times everything here is going to give me that same thing. So that is 2x squared plus 16x plus 32. But this one is 9 divided by 1. That is 9. 9 times x, that is 9x. Then 9 divided by 1 will also give me 9 times 3, that is 27. So now I'm adding like time together. They want to have the same thing, the same variable in the front. So this 2x squared does not have any other variable, so that is just 2x squared. But 16x plus 9x, that will give me 16 because they are having x. So 16 plus 9 will give me 25. That is 25x. Then 32 plus 27, that is going to give me 59. So my answer is 2x squared plus 25x plus 59 all over 9. So this is the answer for f of g inverse of x. So any question you are given, you just need to try to understand the question and you'll be able to solve it. So we are moving to inverse of function. So let's assume we have function like this. F of x is equal to 3x minus 7. So normally this is telling us that when we put an input of x into this function 3x minus 7, we are going to get a corresponding value of output, which is f of x. So the question is now that let's assume that I have my x and y. Let me put some values. So let's assume I put 1 as my x. My y will be, my y, which is the same thing as f of x, will be 3 times 1 minus 7, that is minus 4. When it is 2, it will be 3 times 2, 6 minus 1, that is minus 1. So the question is not like we have an engine, we can always input x there to get y. So the question is that we now want to model another engine that we have to put y there to get x. So we want this y is output before, and this x is input. So we now want an engine that will change this x to output and that will change this y to input. So that function is called inverse of the original function. Inverse of the original function. Inverse of f of x. So when you have a function f of x, x is the input and f of x is the output, then you want to reverse the case, you will call it inverse. And how do you achieve that? It's like I want to always put my y to get my s. Definitely I will make my s the solving formula. That is just the meaning. So if I say my y is equal to 3x minus 7, I can make s solving formula by taking 7 to the other side. So that is y plus 7, then is equal to 3x. Then I will divide both sides by 3. So with this now, I will have y plus 7 all over 3 is equal to x, because this has cancelled this. Alright, so that means my x is equal to y plus 7 all over 3. So for this case where my output, which is y, is equal to minus 1, so when I say my y is minus 1 plus 7 all over 3, so minus 1 plus 7 will give me 6. 6 all over 3 is going to give me 2. Can you see I get my output back? But in a real sense, if we used to call x input, we used to call y output. So to maintain that this x is my input before for f of x, but for inverse I will not call it x again, I will call it y, because generally we all know that y means output, so that nothing will change. And this y has become the input now. So and we all know that we represent x as input, so that is why I change this one to x. So anywhere I see y, I will change it with s, and anywhere I see x, I will change it to y. So if I know now this y is equal to s plus 7 is equal to s plus 7 all over 3, this is the inverse of this f of x. So if I want to write it, I will write it as f inverse of x. Inverse of function of s, that is the meaning, and it's equal to s plus 7 all over 3. That is, anytime I put an output of f of x into this function, I'm going to get the corresponding input of f of x. Do you get? So let's assume that I have another question here. So I have my f of x to be s plus 2 all over x minus 3. So I was asked to find my f of x, f inverse of x rather. So this is what I'm going to do. I'm going to assume my f of x is y. is equal to x plus 2 all over x minus 3, then my x minus 3. So this is my output, this is my input. I want to just reverse the case. So I will have to make x the sort of formula. So this y is same thing as y all over 1. Then I will cross multiply. So this will give me y into bracket x minus 3. Yeah. If I cross multiply, is equal to 1 multiplied by x plus 2. So y times x will give me xy. It can also be written as yx, but I will maintain alphabetically order. So 3 times y will give me 3y. So 1 times x will give me x. 1 times 2 will give me 2. So this is how I got this. Remember, I want to make x of subject for formula. So everything that is having x, I will have to take it to the left hand side, and everything without x will come to the right hand side. So this one is x. If I take it to the other side, it should change to minus. This xy is still here because it contains x. I did not tamper it. But this x, I'll take it to the other side, change to minus x. Then it's equal to this 2 is still here. This minus 3y does not have x inside, so I'll transfer it to the other side. So minus 3y, it will change from minus to plus if you come to the other side. Alright, now x is common to these two. So if I remove x here, this will remain y. X is the same thing as x times 1. So when I bring one x out, it will remain 1. So it's just to 2 plus 3y. So divide both sides by y minus 1 to isolate my x. So with this now, this will cancel this. My x will now give me 2 plus 3y all over y minus 1. So now I have been able to make the input the Sawyer formula. So this I cannot call this my output now for the inverse and call this my input. So to make it normal, I'll just change this x to y and change y to x all over x minus 1. So if I want to write it, I will say my f inverse of x is this function 2 plus 2x all over x minus 1. So that means that if I put any output from this normal function, if I put it in this engine, I'm going to get the input for this function. That is just the meaning. Alright, so let me do another question again. When I have my f of x to be 2x minus 5 all over this 3x plus 1. Alright, so with this now, I'll just have to put this as y, then make it solve formula. I'll try to be fast as much as possible because of time. Alright, so I would cross multiply as well. 3x plus 1 is equal to 1 times 2x minus 5. Then I will open the bracket, that is 2xy plus y. Then 1 times 2x will give me 2x. This is minus 5, not 3. This is 5. So 1 times minus 5 will give me minus 5. So I will take everything that is having x to the left hand side. So that is 2xy. This will come here, minus 2x. Then this minus 5 is here. Y will also have to come here, that is minus y. So x is common now. This will remain 3y. This one will remain 2. Though this one minus is common, so I will bring minus out. This one will remain 5. Remember that minus is minus times plus. Abi? Minus times plus will give me minus. So if you bring one minus out, it will remain plus. So that is plus y. Do you get? Alright, so with this now, we just have to divide both sides by 3y minus 2. 3y minus 2. So this will cancel this. So my x, which is my input before, is now going to give me minus 5 plus y all over 3y minus 2. So to make it normal, I will replace my x with y and my y with x. So my y will now be minus 5. My y have now become x, abi? So 3x minus 2. So my inverse of this function f of x is minus into bracket 5 plus s, or you should write s plus 5. It's still the same thing. 1 plus 2 is the same thing as 2 plus 1. So 3x minus 2. So I'll find the inverse of this function. So let's solve more questions. Alright, so this question is asking us that if f of x is this, you should find the f inverse of x and f inverse of. So we are given another question that if f of x is 5x plus 2 all over x plus 3, you should find inverse of this function and also the image or the output if the input for inside the inverse of the function is minus 6. That is f inverse of 6. So how are we going to approach this? First of all, I told you when we are finding inverse of a function, you just need to make the input the output and the output the input. So they are literally making x the sort of formula. So my f of x, I write it as y. So f of x and y, they are both representing output, so they are used interchangeably. So it's equal to s 5s plus 2 all over s plus 3. So this y is same to as y all over 1, so I cross multiply. So I have y into bracket s plus 3 is equal to 1 multiplied by 5x plus 2. So with this now, y times x will give me xy, 3 times y will give me 3y. Then is equal to 1 times 5x will simply give me 5x, 1 times 2, 2. So I'll take anything that is having x to the left hand side. So this 5x to come here to change to minus 5x. And I have 2 here before. So 3y will come to the other side, it will change to minus 3y. So now x is common to the 2, this will remain y, this will remain 5. So I have 2 minus 3y. So I'll divide both sides by y minus 5 to make this x independent. So I have y minus 5. So x, this will cancel this. So x is equal to 2 minus 3y all over y minus 5. So that means my f inverse of x, which is my inverse of function, is just this y is now my input, but we know that y is always like output. So to make it normal, so we just have to change y to x. That is all it. So that is my answer. So I was now asked to find f inverse of 6. So since I've gotten my f inverse of x, so when my input is x, my f inverse will be 3 minus 2 minus 3x all over x minus 5. So when my input is now minus 6, so my output will simply be 2. I will replace this x with minus 6. So times 3 minus 6 all over x is minus 6 minus 5. Alright, so with this now, this minus and minus will give me plus. This 2, this is minus and minus plus. So 3 times 6, 18. 6 plus 5, minus 6 minus 5 is minus 11. You owe a debt of 6 naira and you still owe a debt of 1 naira. That is total debt of 11. So 18 plus 2, that is 20. Alright, so 20 divided by 11, divided by minus 11. So my final answer is now minus 20 all over 11. It's just like this 20 is same thing as plus 20, and plus is same thing as minus times minus. So 1 minus cancel themselves, this will remain minus at the top. So that's why I have 20 all over. So for this question, what of if you are giving this in an OBJ question and then you have not known your f inverse of x, do you know you can still solve it without knowing your inverse? And how do you do that? Just need to understand the fact that if you have f inverse of x, the meaning is that for the original function, your input for inverse change to output and your output change to input. So in this inverse, they're asking you to find f inverse of minus 6, which is this minus 6 is the input. So you are going to get an output. But if you want to use the normal function, this minus 6 is your output. And whatever you are getting here is your input. Do you get that? Is just the normal way it works. So it's just like if you are told that f of x is equal to y array, this is your output, this x is your input. That means that if f inverse of x is equal to y, what this is telling you is that this x that is here is this y that is here, and this x that is here is this y that is here. What does that mean? That means that if I want to use f of x, this f of x is 5x plus 2 all over x plus 3. So this is telling me that for the inverse, this is input, I'm going to get an output. So since I know that in the normal function is going to be the output and this x is the input, so I'm now looking for input for the normal function to get my output for the inverse function. Do you get it? So all I need now is to cross multiply. So 5x plus 2 times 1, that will give me 5x plus 2. Then it's equal to this minus 6 times s plus 3. You get, so minus 6 times s will give me minus 6x, minus times plus is going to give me minus 6 times 3, 18. So that is going to give me 5s plus 2. So I'm going to take this to the other side. So it's going to change to from minus is going to change to plus. So I have 5s normal here. This minus 6s is going to come to the other side and change to plus 6s. So minus 18, this plus 2 will change to the other side, change to minus 2. 5s plus 6s will give me 11x. So minus 18 minus 2 will give me minus 20. I'll divide both sides by 11. So this is my x is equal to 20 minus 20 all over 11. The same result we got. So that is how this works. So the next question, and it's very similar to the one we just for solving, which I was given that f of x is ax plus 5, and we are given that f inverse of 7 is equal to 4. So I was now asked to find the value of my a and f of x. So how did I do that? Instead of, I can do it in two ways. The first way is to first find the inverse of this function by saying y is equal to ax plus 5. This f of x is same thing as y. Then I want to make s sorrow from loud. Take 5 to the other side. So to change to minus 5, then ax. So I'll divide both sides by 8. So this will cancel this. This y minus 5 all over a is now equal to x. So if x is equal to y minus 5 all over a, so that means that my f inverse of x will be equal to, I'll just change my y to x, my input to output, so all over a. So with this now, I'll now say f inverse of 7. If f inverse of x is this, so f inverse of 7 will be, I'll just change my x to input, which is 7 to, which is x to 7 here. So that will be 7 minus 5 all over a is equal to, and they say the value of my f inverse of 7 is equal to 4. So when I do it, I will get 4. So 7 minus 5 will be 2. So that means that 2 all over a is equal to 4. So if I cross multiply, this 4 is same as 4 all over 1. So that will be 2 times 1, which is 2, is equal to 4 times a, which is 4. So I'll divide both sides by 4. So my a is 2 all over 4, which is same as 1 over 2. But if I don't want to do it like that, I just know that for my normal function, s is the input, y f of x is the output. But this case now, this is the input for the inverse. But if I want to use my normal function, it will be the output. This is the output for inverse. If I want to use it for my normal function, it will be the input. So that means that this output here will now be the input here, and this input here will be output here. So that means that this is my if I want to use this function, this is my input. So this will be my x. My x is input here. That will be a times x. My x is now 4 plus 5 is equal to this output that is input in inverse, but it's output in normal function. So this 7 is now my output. Do you get? So 4 times 7 will give me 4a plus 5 is equal to 7. Then I'll take 5 to the other side, which will change to minus 5. So 4a is actually equal to 2. Then I'll divide both sides by 4. So a is equal to 1 over 2, the same way. So this is quite faster than this, because this will have to find the inverse first, and then now substitute. This one you can do it from the function. You just need to change the input to output and output to input. That is all. Alright, so there is one more question here. Let me divide this space so I can use it for the question. Alright, so the next question I'm seeing here is, if f of x is equal to s squared plus 4, we should find f inverse of x, provided that x is always greater than or equal to 0. The why they are putting this is to tell you that this function has a domain. They are giving you the domain that the input you are putting should always be greater than or equal to 0. If not, there is likely that you are going to hit, and there are some numbers that once they are less than 0, they are likely to give you something that is undefined when you find the inverse. That's why they are saying that. Alright, so we just input y as our f of x. So it's equal to s squared plus 4. Remember, we are making s sorrow formula, so I'll take 4 that is subbing s to the other side, so it will become y minus 4 is equal to s squared. So to eliminate this square from x, I will have to square root both sides, so that square will cancel square root. So I will have x is equal to square root of y minus 4. So with this now, I can say that x is equal to square root of y minus 1. So I can say f inverse of x. I just have to change this x to the input now. I mean to the output input before. I need to change it to output. So I call it f inverse of x. And this y is output before. I change it to input. That is x then minus 4. So this is my answer. Why they are putting it here that x should be greater than or equal to 0 is because of this square root. They know that there are some value if they don't put this domain there are some value that are likely to give what is inside this square root negative, which will not be undefined. So that is why they are trying to define a domain for this initial function. So that is all about that. So if you know the minimum point and the maximum point, so you can know the range. You know the range is like every number between the minimum and maximum. It cannot be less than the minimum and it cannot be greater than the maximum. So for this question, I can actually use differentiation method. But that will looking at this thing, it's something we can differentiate, but there's still some way you can do it algebraically without using differentiation, and that will be quite easier. So this is what you are going to do. So if I know that my domain is value of x that work for this engine, that is that anything outside that will not work. So my range is value the value I can get for my y. There are some it's not all graph that is continuous. There are some graph that are like this. So if a graph is like this, that means that this graph, there is no value you can put for x. It cannot exceed this limit, and also there is no value you can put that will exceed this. There are some graphs like that. They will not be like this. So they will not come down more, and they will not come down more, and they will not go up more than the maximum. They will not come down more than the minimum. So such graph is what the range. They used to have range that is not all real number. It's different from this one that is a straight line that so far you have x, you always have y. That one does not have a range, or let me say the range is all real number. Okay, so for this case now, this is what I'm going to do. I'm just going to make my s solver formula so that it's range I'm looking for. But once I make s solver formula, it has now become like I'm looking for domain. Do you get? So I'll now make the s solver formula by this y is saying the same thing as y over 1, so I'll cross multiply. So that will be y into bracket s minus 1 is equal to 1 times s squared minus 3. I want to make s solve formula. So y times s will give me xy. Y times 1 will give me minus y. So 1 times s squared will give me s squared. Then minus 3. So I want to make s solve formula. So this way I'm taking everything to this side. This is s squared. This sy will come to the other side, which is to minus xy. This y will come to the other side, which is to plus y. And this minus 3, this is it. This is equal to 0. Since I've taken everything on the left hand side, it's remaining 0. So I can say my s squared minus xy plus this y plus 3, I can group them together. If I y minus 3 rather. So if I say this plus times y will still give me plus times y will still give me this minus back. So it's still the same thing I'm writing. It's equal to 0. But because of a reason, I'm going to change this question over to plus. Reason is because that to make it easier for us if we have factorizing. So they will give us a question that it's easy for us to factorize. So what I want to prove is that I want to find the range for this question. So I'm changing this to plus to make it easier for us. Alright. So now if you have s squared minus 5x plus 6 is equal to 0, if you want to factorize, you can use quadratic formula or factorize by saying, if you want to use factorization almighty formula, quadratic formula, you say this is your b, this is your c, this is your coefficient of s squared. So same thing, I want to make s solver formula. So the coefficient of s squared is 1, the coefficient of x here is minus y. So I can say my a is equal to 1, my b is equal to minus y, because this minus and y is the coefficient of this x. So and my c is the constant, which is y plus 3. So that means my x, I'm using almighty formula, is equal to plus or minus minus b, which is minus b is my b is minus y, so minus b is minus y plus or minus b squared. So b squared is minus y squared minus 4 minus 4ab, my a is 1, 4ac rather, my c is y plus 3. It's because of this square root, that is why I change this into plus for it to be easy for us to work with. Alright, so it's equal to 2a, my a is 1, So minus as minus will give me plus, that will be y plus or minus square root of minus y square will give me y square minus 4 times 1 will give me 4. So that 4 that I get, I will now use it to open the bracket. 4 times y will give me 4y. 4 times 12. Okay, so this one too is having minus. So minus times plus will now give me minus. So that will give me minus 12 right over 2a is equal to 2. So we all know that in a quadratic, this is the value, this is my x. So if my y is now my input, now that means that all I'm looking for value that I will put inside this equation that will make it undivided, that will not get any value of x. If I can get that, that is my range. Like that is something that is outside my range. Do you get? So with this, we all know that anything inside square root, for that thing to give us a real number, the thing must be positive. That is, every y square minus 4y minus 12 that I'm doing, it must be always positive. If it is not positive, all these things will not be divine. Do you get? So that means that I can say that y square minus 4y minus 12, which is inside this bracket, must always be positive, unless the whole function is going to affect first going to affect the square. So far it has affected the square, it's going to affect the whole function. We are going to become getting a complex number, which we don't want. So must be positive, and if something is positive, we will say that it is greater than or equal to 0. So any number that is greater than or equal to 0 will be positive. Minus 1 is less than 0 because it's negative. Do you get? 1 is positive because it's greater than 0. 0 does not have negative and positive, so that is why I say greater than or equal to 0. Alright, so I'm just going to factorize this. So factorizing this, that will be y square minus 6y plus 2y minus 12. We all know how to factorize. So y is common, y minus 6 plus 2 is common, y minus 6 is equal to 0. So y plus 2 y plus 2 y minus 6 is my sub. So normal, if y plus 2 y minus 6 is equal to 0, I will say my y is equal to minus 2 and y is equal to 6. So because this one is greater than 0, you just need to know that the one that is bigger is the one that will take this sign. The one that is smaller is going to take the other sign. So it's just y is, because it's great, 6 is greater than minus 2. This is going to take that greater than sign. So y is greater than or equal to 6, and the second one will take the other side. So and y is less than or equal to minus 2. So that means that any value that is less than minus 2 will make this true. Let's test this. If you take y is less than minus 2, minus 3 is less than minus 2. So if I put minus 3 in this function, minus 3 square will give me 9. Minus 4 times minus 3, minus times minus will give me plus. So 4 times 3 is going to give me 12 minus 12. So 12 minus 12 will give me 0. So that will give me 9. We all know that 9 is greater than 0. That means that this thing I write is correct. If you test another number that is less than, or this greater than 6, okay, a number that is greater than 6, let's pick like 7. So if I say 7 square will give me 49. Minus 4 times 7, 4 times 7 will give me 28. So that is 49 minus 28 minus 12. Let's see if the result we are going to get is going to be greater than 0. So minus 28 minus 12 will give me minus 40. Abi? Yeah, so if I say 49 minus 40, that means that 49 minus 40 will give me 9. 9 is actually greater than 0. That means that this stuff I write is correct. So that means that for me to get a real value, my y must always be greater than 6 and my y must always be less than 2. So my range will now be minus 2 is greater than or equal to range, and this same range is greater than or equal to minus 6. That is that this minus 2 is always greater than range. That is or I should say, okay, let me say it like this so that you will not be confused. Let me write it in normal notation. This notation itself is wrong, I'm sorry. So if y is greater than 6, greater than or equal to 6, and this same y is less than or equal to minus 2, so there is no value that can be greater than 6 and at the same time less than minus 2. Do you get? So that is why this one is wrong. So if you want to write it, you say y is greater than 6. So that means that y is starting from 6 and is greater than, so it's going any number that is going in positive way irrespective of how big that number is. So I can say y is from 6 to infinity, like this infinity that is going in positive way. So and also this same y can be equal to -2 or less than -2. So that means that it's starting from a very very less number to -2. Once it has reached -2, it will not work again. So I can say that minus infinity comma -2. So this and this will hold. So I will join it with union. So this is how we write it mathematically. So we now say minus infinity is this, and then union 6 is less than infinity. So this and this, they are the same thing. It's telling you that y is less than -2, starting from the left hand side, from the highest left hand side number. And this union, the union is that and this, the meaning of union is and. So and is also, it can also be anything from 6 upward. That is the meaning of this. So that is just it. And also if you have function like y is equal to 1 over x, when you make x the sum of formula, that is 1 over y. You can still use that same approach. So when your y is equal to 0, when your y is equal to 0, there is no value for x, because when y is equal to 0, x will be undivided. That means that your range for this function x is equal to 1 over y is all real number. Or let me write it like this to be easy. I will say y is all real number except 0. I will now say y is not equal to 0. So this is my range for this function, and for this other function, this is a range. That is that it ranges from any number from negative, any negative number from minus infinity to -2, and union 6 comma 8, that is any number greater than 6. So let's test any value that is less than -2, like -3, into this exact function, and this is going to work. Okay, let me do it like this. Let me test number between -2 and 6, and let's see if it's going to give us x. But to save time, that is it.